All right, let's dive into something that trips up a ton of developers, the technical coding assessment. We're going to crack the code on these things today because, look, it's not really about just spitting out the right answer, it's about showing them how you get there.
So here's the big question, right? How in the world do you solve a problem you've never, ever seen before? Well, here's the secret. You don't need to have seen it. It's not about memorizing 1,000 solutions. It's about having a solid framework, a logical approach that lets you tackle literally anything they throw at you.
And this is absolutely crucial. The interviewer wants to see your brain work. How do you break a big, scary problem down into little, manageable pieces? How do you build a logical path from A to B? Seriously, that thought process is way more valuable than just knowing the answer. It's what gets you the job.
Okay, so let's start building that process. We're going to start in what you'd call the easy tier, with a really common and powerful idea called a greedy approach.
And our first example is going to be the food stamps challenge. It's a classic for a reason. It's all about making the best possible choice at each and every step to get the best possible outcome.
So, here are the rules of the game. Pretty straightforward. You've got N different foods to choose from, and you're allowed to buy M total meals. Every food starts with a taste value, but, and this is the important part, it gets a little less tasty every single time you buy it. It's a classic case of diminishing returns. The more you have something, the less special it is.
So what's the goal? Simple. We want to walk away with the highest possible total taste score after we've bought all our M meals. You got to be smart, right? Because the food that's amazing on your first purchase might be a pretty bad choice by your 10th.
So let me ask you this. If you're standing there, about to buy just one meal, what's the only thing that matters at that exact moment to get the most points?
And there it is. That's the heart of a greedy algorithm. The best move, the optimal strategy, is to just pick whatever food has the highest taste value right now. Don't worry about the future. Just take the best thing you can get at every single step. It's like always picking the ripest fruit you can reach on the tree.
So the whole process just becomes this really simple loop. For every single meal you buy, you look at all your options, find the one that gives you the most points at that moment, add those points to your score, and then you just do it again. Because you make the absolute best choice at every turn, your final score is guaranteed to be the highest possible.
Okay, ready to level up? Now for the hard tier. You know, hard problems usually just mean there are more rules, more constraints you have to juggle at the same time. The underlying logic is often the same. You just have to be way more careful.
Which brings us to our next problem, the lock and parity challenge. Now this one is a great example of where just picking the cheapest or best option every time will lead you straight to the wrong answer, all because of one very tricky rule.
Okay, I know, there are a lot of rules on the screen, but you can pretty much ignore all of them for a second and focus on just one, the parity rule. Parity is just a fancy word for whether a number is even or odd, and this rule says you have to end up with at least as many even cost pairs as you have odd cost pairs. That, right there, is the game changer.
So, when you boil it all down, our goal is to find the cheapest possible combination of keys and locks that follows all those rules, but especially that super tricky parity rule.
Seriously, this one rule is everything. The parity rule is what makes a simple, just pick the cheapest pair approach totally fail. If you ignore this, I guarantee you, you will get the wrong answer.
And here's exactly why. Let's say the two cheapest pairs you can possibly make have costs of 11 and 13. Both are odd numbers. If you greedily pick the pair that costs 11, you now have one odd assignment and 0 even ones. Well, that's invalid, right? 0 is not greater than or equal to 1. Okay, so what if you pick both? Now you have 2 odds and 0 evens. Still invalid.
And this is the breakthrough. This is the aha moment. You literally cannot build a valid solution using only those cheap odd-cost pairs. To satisfy that even greater than odd rule, your final set of pairs must include at least one even-cost assignment. That realization changes your entire approach. This insight gives us our strategy. So first, we find all the possible pairs. We already know that any group of only odd-cost pairs is junk, it's invalid. So what's the simplest possible valid set we can make? Well, it's just a single even-cost assignment. We find the cheapest one of those. In our example, it costs 26. That becomes our new best answer. Now, the last step is just to double-check. Is there any other combination of pairs that's both valid and cheaper than 26? Nope, we found our answer.
So, we've walked through an easy problem and a hard one. Now, let's pull back and turn what we learned into a repeatable strategy you can use for any coding problem.
Here it is, just 4 steps. First, break down every single rule. Don't gloss over anything. Second, find that one core constraint, the parity rule of whatever problem you're facing, the one thing that stops the easy, greedy solution from working. Third, solve for the simplest possible case that actually satisfies that core rule. For our lock problem, that was just a single, cheap, even-cost pair. And finally, you build up from there. You ask, okay, can I add other cheap things to this baseline without breaking my core rule? This turns a massive, intimidating problem into a totally manageable series of logical steps.
And that all leads to a final question I want to leave you with. As you do more and more of these problems, you're going to start to see patterns. So what's the one common thread in almost all so-called hard problems? It's usually that one single constraint, that one tricky rule that forces you to think beyond the obvious choice. Find that constraint, and you've almost always found the key to the entire solution.